Good morning, respected faculty members and my dear friends. So today in this session, I'm going to provide a brief overview of what exactly is Python programming. I hope many of us are already using Python. So in this session, I'll be providing just an overview of what exactly is Python, what are the data types supported by Python, and the different data structures supported by Python programming language. So, Python. Sorry for interrupting. Actually, it's very difficult to see there again. So as many of us might be aware that Python is a very popular high-level programming language that is being used in several applications. So it has gained so much popularity recently because of it is very easy to learn, has a very simple syntax. And Python was proposed by Guido van Rossum in 1991 as Python 0.9.0. So the basic features of Python is a high-level general-purpose programming language, and its design philosophy basically emphasizes on code readability. So we are using significant indentation. Simply looking at the structure of the Python program, we can identify what all blocks are there. So indentation makes it very much readable. Python is also a dynamically typed language and it is garbage collected. The memory management cycles are automatic. So it also supports multiple programming paradigms like structured programming, object-oriented, and garbage collected. And it has a very comprehensive standard library and supports a wide range of applications ranging from like simple applications like where we are plotting some graphs of the data set to very complex applications like machine learning algorithms. So Python basically comes with a integrated development environment called as idle. And other than that, we can also install several other shells like IPython that has improved auto completion, session state retention, syntax highlighting. And there are several web browser-based IDEs like Sage Maths, which is specifically for science and math-related programs. Okay. Sorry, I forgot. I thought this system is connected there to the screen. So there are several web browser-based IDEs, including Sage Math, which is like typically for science and math-related programs. There are other IDEs like Python Anywhere and Canopy IDE. So I've listed the steps that we need to follow to install Python. So this is the official link where you can visit. So Python 3 is the current version. You can look for the current version and install the version that is appropriate for your Windows, be it Windows 64-bit or 32-bit. You can run the installer, select the path, and finally install Python in your system. Make sure you have checked PIP. PIP is basically a package installer for Python. And then to test whether the Python has been installed appropriately or not, you can open the command prompt and type Python. So this will list the displays the version and other information. Then you can type exit to exit from the command prompt, right? And other than this, I always prefer using Jupyter. So to install Jupyter, you can write pip space install Jupyter lab. So this is the command that you can run from the command prompt to install Jupyter lab. And once installed, you can type Jupyter space lab. This will run the notebook that you are interested in creating. So this Python package index, PYPI, is basically a repository of software for Python programming language. So this is basically a community that has over 4,15,000 packages with a wide range of functionality with automation, data analytics, databases, machine learning, whatever you are interested in, you can, I'm sure you can find a package on this in this repository that will be useful to you. So this is how you can create your first Python script. So I was hoping for more of hands-on session. So you can you can open your command prompt, CMD, and then type Jupyter lab, Jupyter space lab. This will open a default web browser with a URL localhost 4x8. So this is the default web browser that is going to pop up. Then from there, you can click on, I've included the screenshots here. You can click on new and then select Python 3. So Python 3 is basically the version of Python that you are running. Then it will enter into, this will open a new notebook, right? So why we call it a notebook is because you have several cells where you can type in the program, and once you press shift plus enter, this will compile the program and print the output there itself. So we are combining input and output in a single unit. That's why we are calling it a notebook. Right? I've included a small program here where I'm declaring a variable A, initializing it to 3, then another variable B, initializing to 4. Then we can add these variables and print it. So moving on to the syntax and semantics. So first is major point is indentation. So Python basically uses white space indentation to delimit the blocks. So increase in indentation comes after several statements, and decrease shows that it is the end of the current block. So a program's visual structure will represent its semantic structure. This is the main advantage of Python over other programming languages. Also, you are not concerned about you have forgotten some semicolons or something like that that used to be the case in other programming languages like C, Java. So recommended indent size is four spaces. These are the several data types and operators that are being supported by Python. So most widely used data types are bool for Boolean value, int, float. These are similar lines with other programming languages that we have been using. So moving on. So class basically is a user-defined blueprint or prototype from which we are creating objects. This is like similar to C++ where we are creating classes, right? For each class, you can create instances which are called as objects. And in Python, you can declare it like with a keyword class space class name. Then you can declare your functions and different variables. So this is the syntax for defining a function. DEF basically represents define, right? Then function name, their parameters, and then there can be optional return statements as well. For input and output, Python has a function input. And you can write the in quotes whatever message you want to display on the screen. And everything that is being returned by input is of type string. So you can perform type conversion like we have done in this code, x equal to int x string. So basically type conversion is required if you want to convert it to some other data type, because default data type is string here. Then you can use print function to display the output on the screen. There is another function init, double underscore init function. So basically this is similar to the constructors that we use in C++. So this is a sample code. It basically assigns value to the object properties and other operations. And there is also a self parameter that is being attached to the current instance of the class. So it also supports the if-else statements like there used to be in the C programming, right? If you want to add check multiple statements. Next is the for loop. So it supports for loop for x in range. So basically range function has 3 arguments: start, stop, and step. Basically start defines the starting index, stop is the end index minus 1, right? So if you want to move from 0 to 4, you'll write 0 to 5. And 1 represents the step count magnitude, like you want to increment by 1 or 2. So the output here will be 0, 1, 2, 3, 4. If you want it to be 0, 2, 4, you can write step as 2. Then while loops are also similar as we used to use in C. So the syntax will be while, the variable that you want to specify the condition, and the statement that you want to print, and then increment the operator. So we can also use break and continue statements here. So Python also supports several data structures. So data structure allows data organization, and along with that, it also saves the relationships that exist between different types of data. We can also perform the operations accordingly. So a Python supports built-in data structures like list, dictionary, tuple, set, and also has several user-defined data structures like stack, queue, tree, linked list, graph, and hash maps, right? So moving on to the first data structure is list. So lists are just like arrays. But the difference between list and array is that it is an ordered collection of different data types. So array used to be a collection of similar data types, and lists are a collection of different data types. So every element is also assigned an index, and index can range from 0 till the maximum index. So this is the positive index. And negative index also starts from -1. Suppose you want to print the list from the back end. So for that, it is -1. This is a small code snippet. So if I can show you, we are declaring the list as list. Then we can specify comma separated values in the list. So these can be of different type, need not be integers or strings altogether. They can be a collection of different types. Then we can access the list using the square parenthesis, like we used to use array A of 0. Here it is list of 0, right? We can all see. So additional to that is that this negative index, list of -1. This will display the last element of the list. So adding new elements to the list, we can use several functions. There is append that can be used to add a new element to the list. We can use the function extend that will add several elements in one go. And index also, there is another function insert that adds the element passed to the index value. And this also increases the list size, right? Then moving on to remove, how can we remove elements from the list? We can, Python has a built-in syntax for del keyword. So this del keyword deletes whatever is passed as argument to this. So we can use delete my list. So, but this doesn't have any return type. So other than this, we can use the pop function that will also return deletes using the index value that is being passed. And it also returns that value. You can save it into some other variable. Like in this case, we have saved it in A. Then accessing the different elements of list. So similar to accessing strings, this is similar to accessing strings in Python. So suppose we are declaring our list with this data values. Then we are using a for loop for element in this list. We can print the elements. Other than this, we can specify in square braces, like the statement, where we can use the index to print the particular data value. So next is a dictionary. So dictionaries are like hash tables. They are used to store the key value pairs. And this is a code snippet for creating a dictionary, like name. Then you can specify the name. For one, we have specified a list. So this again is also a collection of different data types. So you can print the dictionary in one go using print dictionary, or you can access using the key values, like dictionary in square braces name. So you can access an element using this key. And we also have this get function that works similar to directly writing the values. We can change or add some new key and value pairs in the dictionary using, say, we have defined a dictionary, my dictionary, and you want to update the second value. So earlier, second was Java. Once I run this script and I say my dictionary in square braces second equal to C++, this will update the value from Java to C++. We can also add new key value pair. So it can be done using this line itself, my dictionary third as Ruby. So this will add a new key value pair. After second, new entry will be made as third, comma, Ruby. So to delete the key value pairs, we can use the pop function that we used before. So pop, and in braces, you can specify the index that you want to delete. Say I want to delete the third item. So I'll write my dictionary dot pop third. So this will delete the third element from the dictionary. And pop item can also be used to delete the key value pair. So here, my dictionary dot pop item will delete the key value pair from the dictionary. Okay, moving on to accessing the elements of a dictionary, we can use the get function. So once we have declared the dictionary, we can write my dictionary dot get second. So once you pass the key, it will print its corresponding value. So get second will print Java here, right? In this particular example. Next is tuple. Next data structure is tuple. So I was told to cover the basic data structures today. So third data structure is tuple. So tuples are also similar to lists. The only difference is that they are immutable. That you cannot make changes to the list once it is being created, right? Earlier we updated the value of second from Java to C++. That can't be done for tuples. So to create, we use the tuple command. Say my tuple, I'm creating this tuple with value 1, 2, 3, and Python. So again, mixed data types are there. They are being supported by this one. For X in my tuple. So earlier I showcased a basic example of for loop where we are moving from 0 to some particular value. We can also include these data structures here, like in this case for X in my tuple, right? Where, until this my tuple entire field is not covered, it will keep on looping and print X. So this will print all the values one by one, first 1, 2, 3, and finally Python, and then the loop will end. Also, if you don't want to print the entire loop, you can again access it using the square braces, like we do in case of arrays in other programming languages. So appending elements to this tuple, you can use plus operator. So updating the tuple is very important. So you can, being immutable means you cannot change the already contained values, but you can always add new values to the tuple using this plus operator. So other functions are also similar to list, right? We can count the occurrence of a particular value, like in second last example, my tuple dot count 2 will return the number of times 2 has appeared in this tuple. So other than this, we have index function that will print the index of that particular value. So the last data structure is set. So set is basically an unordered collection of data that is mutable. So earlier was immutable. This one can be changed. This is mutable. But the major property is that it doesn't allow any duplicates. So operations are also similar to arithmetic sets. So how can we create a set? Suppose I give my set as 1, 2, 3, 4 and 5, 3 times 5. So as I've said, that set doesn't allow repeated values. Even though you are providing 5 3 times, once you create it and print my set, this will display 1, 2, 3, 4 and 5 only. 5 will be entered once, not 3 times. So we can also use add function here to add a new data item to set. Moving on to the operations in sets. So these operations are also similar to arithmetic sets that we have been studying so far, like union, intersection, difference is there. And additional to that is symmetric difference. This symmetric difference is similar to difference, but it only outputs the residual data in both the sets. So once we have declared my set 1 and 2, right? So you can either type union or you can write down this pipe operator. These are same, right? This is just to showcase that you can use both. Next is intersection is for AND operator. Set difference is minus and symmetric difference is this tilde. So that's all for today's presentation. I was hoping more of hands-on where I could help you out for creating new scripts.